Hi, welcome to Office Hours. My name is Patrick Curran, and along with Dan Bauer, we make up curran-bauer Analytics. In this episode of Office Hours, I'm going to continue our discussion of the structural equation model. In the first episode, we gave a general introduction and talked about the 6 basic steps that we take in conducting an SEM. In the second episode, I introduced path analysis. In the third episode, I introduced factor analysis. And in this episode, I'm going to bring together elements of the path model and of the factor analysis model to define what is most often referred to as the structural equation model. So we were working with an example in prior episodes of looking at what are mediators of the effect of parental alcoholism on adolescent substance use. And a part of that mediating pathway was parental alcoholism led to increased stress in the home. Increased stress led to increased negative affect, depression and anxiety, which in turn led to substance use. All right, so this was, we had a more complicated model that we looked at in the path episode, but this is a simplification of it, is that we had stress to negative affect to substance use, and we talked about how do you estimate and evaluate direct effects, indirect effects, how do you test mediation. There were a lot of advantages to this model, particularly over the more standard multiple regression model. But one of the limitations of this that we discussed is the path analytic framework assumes that all of our measured errors are assessed error-free. There is no unreliability in our measures. Now, we know that in settings like these, and many settings like it, that is a patently unrealistic assumption to make. Is if I'm evaluating a kid and I'm giving them some questionnaire or some assessment battery, and I ask about stress in the home, I ask multiple items about depression and anxiety, I ask multiple items about quantity and frequency and impairment of substance use, is adding up the items and dividing by how many there are is not error-free. There is some unreliability that's embedded within that. If it exists and we don't account for it in the model, what it does is drives these relations down. All right, so these are regression coefficients, say beta hat 1 and beta hat 2, is on average, those are going to be smaller than they should be because we are not accounting for unreliability in the measures. It's called attenuation, and it's a real limitation of the path model. We already have a challenge in our fields of small effect size and low power, and this is just kind of a poke in the eye of one more factor that's pushing down our effects. So then we transitioned and said, okay, well, if that's the problem, if that's a limitation, what can we do to address that? Well, what we did, I'm just gonna give up, is in the next episode we said, well, one of the distinct advantages of the SEM is we can define and estimate latent factors, all right? So there's a whole episode on this in which I explore what it means to have a latent variable, and the rectangles are measured items and the circles are latent factors that we believe to exist but we did not directly observe. All right, these top single-headed arrows represent residual variances on the item. That's the part of the item that is unexplained by the underlying factor. And these single-headed arrows that link the latent variable to the indicator, those are called factor loadings, and they literally operate like regression coefficients. Is a 1 unit change in the latent variable is associated with a lambda unit change in the expected value of the outcome. So we talked a lot about this in the prior episode about the confirmatory factor analysis. So it's confirmatory because we're imposing certain structure in the parameter space, right? We say that these 3 items relate to stress, but they don't relate to negative affect. So we're fixing those parameters to be 0. We estimate the model and then compare the fit of that relative to the characteristics of the sample that we observed. And there are a lot of advantages to this. But notice one potential limitation, at least from a theoretical standpoint, is the factors are all related to one another using these curved double-headed arrows. And in a prior episode, we talked about how in path models, those represent covariances. They're sometimes called non-directed effects. It means that stress is correlated with negative affect, but this model does not impose a structure on it. It does not say stress in part determines, or, using the term carefully, that stress partially causes negative affect. This model doesn't imply that. What this model implies is stress is correlated with negative affect. They're in some way related to one another, but one does not determine the other. Kind of a simple example to think about that is height and weight. Height is correlated with weight, but we're not saying that height causes weight or weight causes height. All we're saying is on average, taller people tend to weigh more, shorter people tend to weigh less. And so that's going to be captured in the covariance. But notice what our temptation is here is, given what we know about the path model and being able to estimate directed effects and use those to test mediation, and given what we know about the factor analytic model, in which we are able to incorporate multiple indicator latent factors to estimate and remove the effects of measurement error, there is a logical step forward in which we take the latent variable model and we reparameterize these covariances as directed effects. So now we have a residual variance on negative affect, right? The residual it's a dependent variable. In SEM, this is sometimes called a disturbance, and it's that part of the latent factor that is unexplained by stress. And we have the same, it's a dependent variable for substance use. And notice that it's just a logical combination of the concepts in the path analysis model with the concepts in the confirmatory factor model. And in that way, it's kind of funny is the full SEM is often kind of anticlimactic. Is when Dan and I teach this in our summer workshops, is we have a huge amount of material on path analysis, we have a huge amount of material on factor analysis, and then when we hit the SEM, we keep saying, well, we've seen this before, and that's exactly what we have here. Is what we've achieved in this model is we are we're accepting that our set of indicators contain some measurement error, right? It's not measured perfectly, and that we're going to use the multiple indicator latent factors to estimate and remove the effects of the measurement error at the level of the latent factors. And then what we get in exchange for that is these regression coefficients. Remember a moment ago I said that in the path analysis they're attenuated for unreliability. They're smaller than they should be. In this model they're disattenuated. These are not. Is the expected value of this regression coefficient, meaning if we were to repeat the study an infinite number of times, the mean of all of those would be equal to the population value. That doesn't hold in the path model. So there's a real advantage in doing this. So that brings us to the 6 steps that we talked about in the very first video, which is we start with specification. All right, so let's think about different ways that we can build this model. So I'm going to knock off one of these latent variables, and I'm going to rename a couple of these just to make it easier. Let's say that we are just looking here at stress and we have negative affect. All right, so we could estimate multiple indicator latent factor for stress, multiple indicator latent factor for negative affect. Remember, our motivating question was, how does stress and negative affect mediate the effects of parental alcoholism diagnosis? So we have a manifest variable, right? It's a rectangle, meaning we observed it directly, and we call it COA. That stands for child of an alcoholic, all right? So it's a 0 if the child has neither parent is alcoholic, and a 1 if at least one parent is alcoholic. And then we have biological sex, all right? So that's an observed variable, 0, 1. And then maybe we have age, all right? So that's an observed variable, is years since birth, all right? And so we can correlate those. Remember, the general rule is we always covary all exogenous variables, because that allows us to have unique interpretations. That is, one predictor above and beyond the other. And so then we can estimate regression coefficients like that. And now, again, we see the similarities to the path model that we had in earlier episodes, but now we are under assumptions. If we're meeting assumptions correctly, we have an error-free estimate of stress and an error-free estimate of negative affect. So now we can talk about what is the mediating effect of COA on negative affect through stress. So this is one example. We can have a combination of manifest variables. We can have a combination of latent factors. Now we can have on down, I'm kind of out of room at the bottom here, so I'll start working my way down, is maybe we have some outcome here of deviant peer affiliations, all right? Because that's kind of a training ground for delinquent behavior. So we have deviant peer affiliations, and we have the kid report on, a set of items about characteristics of their friends and their group and things like that. And so here we could have a broader mediating pathway. This could be some outcome that's just a measured variable itself. It could just be a manifest variable. We can have any combination of these. Now, as you can start to see, is as we move to the SEM and start including latent factors, the specification step of the model building becomes increasingly more complicated. If we only have 3 or 4 or 5 measured variables, there are only so many ways we can draw that path diagram. There are only so many ways that we can relate variables to one another. But as we start to use multiple indicators, we start to have multiple latent factors, there are many more sources of potential misspecification in this model. We have to make a lot of very strong statements about these 3 items relate to stress, but they do not relate to the predictors directly. They do not relate to the other latent factors. And so it becomes more challenging. And remember, our best compass as we're doing this kind of work is drawing on theory. And so we want theory to dictate how we parameterize this model, but theory only goes so far. And at times we're going to have to look to the empirical characteristics of our data to determine if we establish the correct specification or not. Okay, so the next step we move to is identification. Remember, we talked about that being, do we have enough observed information to uniquely define the parameters that we want to estimate from our model? These regression coefficients, these factor loadings, these residual disturbances. Notice there are many, many more parameters here to estimate because it's a more complicated model, but we also observed more information. We have all of these individual items that's contributing to the unique information we have. As in prior episodes, I'm not going to go into detail about model identification because it is a bit more complicated and take more time. But a model such as this, I can look at it and just using some heuristic rules that Ken Bollen describes in his 1989 textbook, I know this to be identified, so we've hit the identification phase. Then we estimate it. We usually use normal theory maximum likelihood. That assumes all the dependent variables are continuous. And so we can estimate that. Then we have to turn to model evaluation. This is also harder because there are many more parameters in this model that are restricted, right? Is before, if you think about a 3 or 4 variable path diagram, we may only have, path analysis, we may only have 1 or 2 or 3 parameters fixed to 0. And those values that are fixed to 0, those parameters that are fixed to 0, are contributing to model misfit. So if we have a model chi-square or fit indices. Here, look at all the parameters that are fixed to 0. These 3 items are allowed to load on stress, but every other possible parameter is fixed to 0. And so it becomes it's an increasingly challenging test of our hypotheses, but that's a good thing, right? This is we have a lot of power, we have a lot of degrees of freedom, and this is a very rigorous test of our theory. One of my favorite philosophers of science is Karl Popper, and he talked about putting our hypotheses in peril, is we want to make these high-risk statements that we can bring empirical data to bear to make some evaluation of our theoretical model at hand. And so we do model evaluation just as we did in the path model and in the confirmatory factor analysis model, is if the model is deemed to fit well, and in the next episode I'll talk about how do we evaluate model fit, but if we have a low chi-square relative to our degree of freedom, we have high fit indices, we have small residuals, then we can say that the parameterization of my model is consistent with the characteristics of the data that I observed. If it fits poorly, and I would have to say in a model of this complexity, I forgot a residual, there we go, a model of this complexity is, if it is a reasonably large sample size, this model may not fit well on initial estimation because there's so many restrictions that we have placed. Is we can do two things, as we've talked about before. We can use what are called likelihood ratio tests to introduce theoretically driven parameters and then evaluate if there's a significant improvement in model fit. So maybe theory says, well, COA would also have direct effects on negative affect and on deviant peer affiliations. I'm going to add those two parameters and see if the addition of those parameters significantly improves model fit. The second one, which is dangerous but powerful, they go hand in hand, are consulting modification indices. And as I've talked about before, the model, those are totally analytically based, they are agnostic to theory, and they just give you an estimate in how much your chi-square will go down if you free each parameter individually. All right, so every single one that's fixed to 0, you're going to get a modification index that says if you were to free this, your model would improve by this much. It ranks them from biggest to smallest, and that gives us hints about where misfit may exist in our models. And those are helpful, those are useful, but they're also very dangerous because they're atheoretical, they're data-driven, and they're difficult to replicate. But it's another piece of information we can use in evaluating our hypotheses. All right, so we can consider potential respecifications, and then when we've established, hopefully, the parameterization of our model is adequately reproducing the characteristics of our observed data, then we can do what we did before and say, well, can we evaluate mediating mechanisms? So we could test an indirect effect of COA to stress to negative affect to deviant peer affiliations. And I'm going to just put those in green to highlight. As we talked about earlier, that's called a specific indirect effect, meaning that it's a single mediated pathway. And in any major SEM package, we can get an effect decomposition, it's called, and we can get a test of does stress and negative affect significantly mediate the relation between COA and deviant peer affiliations. But in doing it in this way, we are estimating and removing the effects of measurement error so that this is a less biased, more accurate estimate of that indirect effect. And so that's a significant improvement over the manifest variable path analysis model that we talked about before. So in a nutshell, that is the general structural equation model. Is, again, there's no fixed definition of what is an SEM. Some people refer to path analysis as an SEM and confirmatory factor analysis as an SEM. I had the honor years ago of taking SEM from Peter Bentler when I was at UCLA, and he liked to refer to these models as multivariate models with latent variables. And I really like that phrase because that's what it is. It's a multivariate model with latent variables. So we can have any combination of latent factors, of observed variables, of mediators, distal outcomes, but as your model gets more complex, it becomes more difficult to specify it, to lay out how things relate to one another in a principled way guided by theory, and evaluating it. These become increasingly hard to establish proper model fit. and allow us then to make inferences back to theory. And so that's going to be the topic of the next episode, is given path analysis, factor analysis, SEM, how then do we say, all right, I've estimated a model, how do I know if it adequately reproduces the characteristics of my data or not? And we will talk about that next time. So as always, thank you very much for your time.